Good afternoon. My name is Rachel Hendrickson, and I am a marketing manager with DLT Solutions. I want to thank you for joining DLT and Hortonworks this afternoon for the Big Data Insights for Big Real-Time Enterprise Security Protection webinar. Our presenter today is Matt Kerr, a solutions engineer for Hortonworks, and he is responsible for the strategic direction of the big data solutions that Hortonworks offers to customers in these organizations. He has more than 25 years of experience in the IT industry, and today he will be providing you with an overview of the Hortonworks Cybersecurity Platform and explain how Hortonworks takes a data science approach to cybersecurity. With that, Matt, I'm going to turn it over to you.
I've been with Hortonworks for about 2 years, according to the amount of LinkedIn congratulations I've gotten over the past couple days. I think it's exactly 2 years. And today we'll be talking about the Hortonworks Cybersecurity Platform. And so to briefly go through what we are going to cover, and I hope everybody can see my slides. So we're going to briefly talk about the parts of the platform, the underpinnings of the platform, and then we'll actually walk through why how we've built the platform on top of those is important. We'll actually discuss the business case for why you want to use a big data platform as a cybersecurity platform. And then we'll walk into a little bit of detail about what sets the cybersecurity platform apart from some of the other platforms, and really what's the special sauce about HCP. And we'll walk through how it ingests the data, how you can actually enrich the data from other sources, and we'll do a deep dive on what we call the profiler, which is really the heart of some of the interesting capabilities for doing behavioral analytics within the platform. And last but not least, we'll walk through what that looks like from an analyst perspective as they're actually sorting through the volumes of data that they need to sort through to be able to identify that needle in a haystack when they're trying to identify malicious behavior on the network. And then I'll try to leave some time at the end for questions and answers. So if you have any questions, I believe there is a way of putting them in, and Rachel will get those to me when we conclude the presentation. So just a little background. So the Hortonworks Cybersecurity Platform is built on top of the two platforms that Hortonworks provides support for. The Hortonworks Data Platform, or HDP, was the first platform that we supported as a company way back when. It is our Hadoop, our enterprise Hadoop platform, our big data platform, capable of scaling to the hundreds of petabytes of storage across thousands of servers. We have customers who are currently operating greater than 400 petabytes of information on a single cluster, and that cluster running at over 1,000 nodes. So we can definitely expand the platform to a very, very, very large scale for data storage and analytics. And so that provides the foundation for the data that we're storing as part of the cybersecurity platform. And then the second piece of this is our Hortonworks Data Flow. Hortonworks Data Flow is predominantly oriented around a Apache open source project called NiFi, that was originally developed at the National Security Agency over a decade ago, that was released into the Apache open source community a couple years ago. We acquired the company that was spawned out of the NSA to support that. So now that piece of software is a core part of our Hortonworks Data Flow. And we use that for the ingesting of the data for all the different telemetry sources on the network, intrusion detection systems, syslog, and the like, and we'll go into that in a bit. But the cybersecurity platform is built on top of those two platforms, and we'll go into detail about that in the upcoming slides. So the cybersecurity platform is powered by yet another Apache project called Apache Metron. And so Metron is built on the capabilities I mentioned to provide for real-time ingestion of the data from the telemetry sources you have on your network, whether it's system logs, intrusion detection, packet capture, pretty much any data source that you can think of on your network, we can ingest and incorporate as part of the data processing pipeline to do analytics on. That data is provided in real time to a cybersecurity dashboard for visualization and analytics. We can incorporate real-time enrichment of cybersecurity feeds, whether they be sticks, taxi, or other types of structured data feeds that you would like to incorporate for enrichment. We can also integrate as part of the enrichment pipeline machine learning models. There's a model as a service infrastructure within the pipeline to be able to deploy and manage those models within that enrichment pipeline. And then last but not least, because we are using the Hortonworks data flow capabilities for the ingestion, that also allows us to very easily integrate with other existing analytics tools and SIEM tools, and we'll discuss that a little bit later on as well. So just a little bit of background about it, since one of the questions I often receive is, well, is this a new product? Because Hortonworks started supporting this in 2017, and I wanted to, basically say, no, this is something that's actually been around for quite a while. It started in, I believe the development started in 2013 as OpenSOC and was in development as the OpenSOC platform for several years before it transitions to be an incubating Apache project in 2016. So we have helped shepherd the Apache Metron through the Apache process to get that to be a top-level project. And in 2017, we began offering that as a supported product as part of our portfolio of applications here at Hortonworks. And HCP 1.5 just came out, I think, within the past couple of weeks. So we do see new releases fairly frequently and are constantly incorporating new capabilities into that platform. So it's a very rapidly evolving platform as well. So getting into some of the reasons about why somebody would want to use HCP and the advantages of running on a big data platform. One of the big challenges that we see across the board is that a lot of the existing current solutions just are not capable of scaling to the amount of data that you need to be able to preserve in order to understand what is the impact of breaches that have occurred on your network. And so, the average time, and I have a slide here in a bit that talks about the average time for a breach to be identified on your network versus the average data retention for a lot of organizations. And you'll see the gap here is that if it takes 8 months to find out that we have a breach on our network, and I only have at most 6 months of data to actually understand and sift through, I do not understand what the scale of that breach was, nor what the impact of that breach was to my network. And we often see this in a lot of the publicity we now see for some of these large-scale commercial breaches, where those the initial impact estimates are continually revised upwards from what they think the initial impact is on their network. So in order to have an effective platform for doing cyber analysis, you need to be able to start with a platform that can store a large amount of historical data. And that's where our underlying HTTP comes into play, is to allow us to store that petabytes of information in a low-cost commodity infrastructure storage mechanism. So here's just a further breakdown of some examples of what that would look like. So some very well-known breaches in the news and how long it took for those breaches to be identified on the network versus what the average silo retention was for those. So you can see the vast difference in terms of how much data people are storing versus how long those breaches are going on undetected on their network. So now let's dig into a little bit more detail about how the Hortonworks Cybersecurity Platform addresses some of those challenges. So this is a high-level overview of what the infrastructure, what the architecture looks like for Apache Metron. So you have all kinds of different telemetry sources on your network, and everybody's environment is unique. They have their unique combination of servers, of protocols, of different systems that they're using on their network to do endpoint, security endpoint devices. Different ways they may be ingesting machine logs. So you might have Windows servers with Windows event collectors. You maybe have syslogs. Maybe you have login information coming from places like Active Directory, firewalls, virtual private network devices, all sorts of different devices that combination is going to be unique to your network. Maybe you're also using intrusion detection devices. And then last but not least, maybe, especially for some of that forensics, you care about preserving the raw packet capture data associated with that. In a lot of the environments that I've seen for some of the customers I've worked with, oftentimes those systems are a wide variety of non-integrated sources. So for an analyst to be able to go understand what the impact of some event that occurs on his network, he may have to look at 4, 5, 6 different sources to take a look at the logs for a system, take a look at the raw packet capture. And it becomes a very difficult, slow, burdensome process to understand what happened in response to an event that might show up in their existing SIEM tools like ArcSight, for example. So that's one of the challenges that Metron is meant to address, is to provide that single pane of glass, that single tool to ingest and process all that data together. And we'll see why that's important in a little bit, because you may actually want to look at all of that context together when understanding what happens on your network and when you're doing that investigation. So then we use NiFi in that second green box to the left to be able to do that ingestion. And I'll show you what that looks like in a couple slides. The really nice thing about NiFi is that it's an extremely intuitive graphical tool. I've heard it described as essentially the Visio of data, to be able to integrate your various different data sources into the Metron pipeline. It's a fairly powerful capability on its own right, and probably could do another 2-hour webinar on it alone. But just to summarize sort of some of the interesting use cases for what we see it used for alongside of Metron, I don't think I've ever seen an environment where we walk in and a customer does not already have a set of tools already deployed, whether it's a SIEM tool like ArcSight. Maybe they're using some existing tools like Splunk or Squirrel to do some of the other analytics. One of the things that NiFi is very, very good at is being able to integrate those environments all together, so that I can take NiFi, bring in the data from all of these different data sources into my data flows within NiFi, and then filter and route that data appropriately to those specific analytics systems as necessary. And where that comes in handy is, so Splunk is, for example, very, very, very good at what they do in terms of analytics. A common, I don't know, complaint, but a common concern I hear from people is that their licensing scheme, sometimes costs a lot more, and people are sending Splunk a lot of data that it's not necessarily using. So one of the first questions I hear is, okay, I've got Splunk. How can I use this with Splunk? Well, we can deploy Metron and actually use NiFi to ingest all of those different data sources, and then use it to intelligently route and filter data to those downstream analytics systems where they're only going to be receiving the data they need. So now maybe I'm sending a significantly smaller amount of data to Splunk that's not going to impact the analytics that it's able to do. However, it allows you to maybe be a little bit more optimal in terms of your licensing scheme for how you acquire those Splunk licenses. And at the same time, you don't want to throw data away, which is where the HDP, I think, is really stands out, because you've got a commodity, low-cost, redundant platform for now being able to store all that data that maybe you're not sending to some of those other analytic tools. And like I said, we've got this proven at scale in production where we are running at the hundreds of petabytes level, which I think is pretty much larger than any of the other analytic tools that are out there that I've seen today. So once the data is passed along from NiFi into Metron, it enters a streaming data pipeline. So this is all processing that is done on streaming data. This is not writing it to a database and then reading it back out in some type of write and query fashion. This is all built on streaming data technology. So it goes through this pipeline very, very quick for real-time enrichment for large amounts of data. And I'll discuss sort of how we do that, because some of the enrichments, especially if you're talking about ingesting data at upwards of 25 megabits per second, really aren't possible without doing some of the more advanced analytics and some of the capabilities with tools like, or functions like hyperlog log, for example, or Bloom filters that can very quickly process sets of data which wouldn't be possible if you were going to process them in your sort of traditional ways of handling those sets of data. So as it passes through this pipeline, this is where all of the enrichment happens. That can be enrichment from threat intelligence sources. So obviously we can do things like sticks and taxi feeds. But we can also do enrichments from pretty much almost any type of structured data set that you can think of. So as long as you can get it into a structured format that we can then pull into HBase, which is the NoSQL database we're using underneath the hood to provide the storage and lookup for those enrichments, we can use that data source as an enrichment. We can also, and I'll touch on this in a later slide, deploy machine learning models. So if you are storing all of this historical data in HDFS, you can now build machine learning models that you can deploy and enrich in real time as part of this pipeline as well. So if you've got models that you want to deploy, just pulling some off the top of my head, like for example, you build a machine learning model around whether or not a domain name is a machine generated domain name. That often is an indicator of somebody, a botnet, for example, reaching back to a command and control host. Maybe you want to determine, is the domain name associated with this IP address potentially a machine generated one? Or is this domain name possibly a variant of a name like a typo squat where they're using either characters or a misspelling of a domain name to try to squat on a domain name as well. So those are types of things that we can use as models. Those are very simplistic examples. Obviously, we could deploy much more comprehensive and complex ones based on the data that you're storing in your platform as well, and we'll discuss that in a bit. And then the heart of this is really the profile, and I want to dive into that in a little bit more detail on some slides in a second before I wrap up. After I wrap up this overview of the pipeline. So after you've completed all of your enrichments, so added all these additional attributes to the records as they flow through the system, you can then also use that same pipeline to to triage that data with scores so that you can actually prioritize those alerts in the dashboard for the user. So if I have an event that shows up that is something I care about taking a look at, but it might be somewhat of a lower priority, maybe I triage that with a score of 10, whereas there's another profile that I deploy that is crucial that we bump that up to the top of the priority list and we triage that with a score of 100. And I'll show you how that works and what that looks like in some screenshots coming up. And then last but not least, on the far right, so we're able to integrate this now with many other different downstream tools for processing. So as part of the platform, we can land all this data into the Hadoop Big Data Lake for analysis, where we can use some data science tools like Zeppelin or Spark, or we can use Hive, pretty much whatever your big data tool du jour is that you would like to be able to have your analysts use to sift through that data, we have access to for them to be able to do that ad hoc analysis. But we can also forward that data to and integrate with, like if you're using your own case management systems, if you've got evidentiary stores. So however you want to process and use this data downstream, we can also use NiFi to very easily integrate with any other tools that you have in your environment or downstream data requirements you might have as part of your cybersecurity analysis. So this is it at a high level. To dig into a little bit more detail and actually get a little bit more technical now, this is what the pipeline actually looks like and sort of the different products that we're using underneath the hood. So as I mentioned before, we're using NiFi to do the ingestion. We use Kafka. If you're familiar with Kafka, Kafka is essentially a message capability that is used at very, very, very high capacity by a lot of your social media companies. I know that LinkedIn uses it, but it's capable of handling billions of records per day. Very, very, very high throughput for processing large amounts of data very, very quickly. And then we're using Storm, which is a streaming data capability, streaming data processing capability that can be deployed and horizontally scaled on top of our data platform for doing all that parsing and enrichment and profiling that you see in the middle with the parsing, enrichment, and threat intelligence stages. After it has gone through all of that processing and enrichment pipeline, the data is ultimately written to either Solar or Elastic for indexing, for a very, very responsive analytic capability for the users. So, you would land a lot of that most recent data that analysts need to take a look at for triaging. You would land that so they can very, very quickly, in a matter of sub-seconds, sift through and drill through all that data to set the context for whatever they want to look at for whatever event or alert that they're trying to identify what happened on their network was. But at the same time, also write all of that historical data to the Hadoop file system, where we can actually create policies to store that data, either hot data on SSDs. Maybe you move some of that after some period of time to a slower spinning disk for warm storage, and then ultimately maybe set policies for 6 to 12 to 18 to whatever plus your retention period is. You can move that off to cold storage as well, but still have it online in your HDFS cluster for analysis. And then we can pass that off to other tools for analyst use, like Zeppelin, data science notebooks, or Apache Spark if you want to build machine learning models and whatnot. So this is the processing pipeline, sort of the 30,000-foot view. I'll briefly walk through what that would actually look like if you haven't seen the pieces. So to start, here's what the interface for Apache NiFi looks like. And so it really is sort of that intuitive drag and drop Visio for connecting systems together, the details of which is probably the subject of another webinar, because you can really cover a lot of different capabilities here. But the point that I want to make is that it is extremely easy to integrate the different data sources that you have on your network with Metron. The current version of NiFi in HDF comes with about 220 processors for ingesting data, processing data, and writing data to different data sources. So I have not yet come across a data source that we were not able to very easily ingest via the drag and drop interface and put into Apache Metron. So it makes that integration in your environment extremely, extremely simple and intuitive. The next piece I mentioned was some of the enrichment now. So one part of the enrichment would be using machine learning models. I think almost every single RFP or question I see come out about cybersecurity capabilities is, how do I deploy machine learning models into my processing pipeline to understand those threats that maybe we can't detect with traditional signature-based approaches? So within Metron, within HCP, there is a set of infrastructure that manages the deployment and service discovery of those models of a service that you can deploy within that processing pipeline. And it's essentially language or technology agnostic. As long as the model can be exposed as a REST interface, it can be executed by the Metron pipeline for enrichment. So if you've got something written in PHP, if you've got something written in C, if you've got something written in Spark, as long as it can be deployed as a REST endpoint, it can be integrated into the model as a service pipeline for enriching the data as it flows through. So lots of different things that we can enrich it with as a model as a service. The example you see here is where maybe you're building a machine learning model off your historical data source, and you want to actually continually train and update and deploy that with new data on some periodic basis. That infrastructure exists within Metron to be able to do that. The other types of enrichments we often see people ask about is, there's some very simple ones. For example, lookup type of information. Could be as simple as, okay, I want to geo-reference this IP address. What's the country code, latitude and longitude associated with a particular IP address? Maybe it's just something as simple as looking up against a static list of malicious IP addresses that you are getting from some external source. Maybe it's a threat intelligence source that you're getting from a Stix or Taxi feed or somebody like Soltra. All of those can be integrated into the processing pipeline to enrich the data as it flows through those different enrichment steps. And so as each piece flows through, you'll notice that last bullet, it's, as it passes through the system, each subsequent enrichment builds on top of the previous one. So I may have machine learning enrichment and a geo IP enrichment and a threat intelligence enrichment and a lookup enrichment all flowing through on a record as it flows through the system. So what I want to spend the most time on, because I believe this is sort of the special sauce for Metron, is this enrichment called the profiler. And so what the profiler is an engine that sits on top of that processing pipeline and has visibility to all of the data flowing through the pipeline, where you can build profiles of not only data within a particular data stream, but maybe even across all those data streams together. And what do I mean by that? So one of the challenges, if you're taking a look at enrichment for a single message, right? I'm getting a syslog entry, for example, and I have maybe an IP address in there that I want to geo-reference. Well, that I can do a simple lookup, but that enrichment only happens in the context of a simple message. If I actually want to look across windows of time, if I actually want to build up a statistical model of certain behaviors of that, or everything across the system, I need to be able to look at all of those data sources within that window of time. And that's the problem that the profiler is really meant to solve, is it creates these logical windows across all of the different data sources that are flowing through the pipeline to be able to operate on all the data within that window. So I can do simple things like maybe I just care about doing an aggregation over a window of time of how many systems has a user logged into. But I could also do some more complex ones. Maybe for some reason you care about the ratio of DNS traffic to HTTP traffic. Well, if I've got one data source that's providing the DNS information and another data source that's providing my HTTP telemetry, I actually, within the profiler, can create a profile on each one of those and then create a third profile that is a ratio of the two of those together. So now I have a new piece of information that is created and enriched by looking across and comparing two completely different pieces of information within that window of time. And you can use this to create some very, very, very powerful enrichments that I'm going to get into here in a bit. So, but just to give you an idea of what it looks like, to sort of dispel the myth that this is something that's extremely complex, there's really only a handful of pieces to developing a profile. So, right now we have to build those in a simple JSON format. The biggest #1 request we get is, can we have a user interface for building these profiles? Believe me, we hear everybody loud and clear that that's something that needs to be done. So, that's something we are working on. But essentially what you're doing is that profile name is essentially creating a variable called test. I'm basically saying for every single IP address that I see flowing through the system, I'm going to start for this window of time by initializing it to 0. Every time I see that IP address, I'm going to increment that count by 1. And at the end of the window, I'm going to, that's going to result in a attribute with the count of times I've seen that IP address flow through that window of time. This is a very simple example of what a profile would look like. But now you can do some very complex things with that. So within Stellar is a domain-specific language that's part of Metron. You can do much more complex calculations across the data that exists within that profile window. I can do distributional statistics. So I can create median, mean, percentiles. Create that standard distribution based on the data that is flowing through for each data source. I can do set operations with cardinality, and these are the ones I mentioned before, where we actually have those functions and those data structures which are able to operate at very, very high speed, like the Hyperlog, Log Plus, or Bloom filters that are approximations, but they're very, very accurate approximations that don't need, the same, they need, orders of magnitude less space and orders of magnitude less time to be able to arrive at a result that's within 1 to 2% of that same level of accuracy, which when you're dealing with, 25 megabits per second of data and potentially petabytes of data, you need to be able to do it that quickly without, having the memory budget of gigabytes of storage on your box in terms of RAM. So what do I mean by, how can you use these statistical functions? So let's go through and walk through what that might look like in more detail and give you a much more interesting example. So let's say, for example, we had authentication information that we were pulling from a data source. It could just be something as simple as log on, log off information, invalid login information. And what I want to find out is, I care about, is a user on my system logging into more systems than some of the other users on the system? And so what I can do is I can create profiles that I can then use to create enrichments around that. So in this example, the first profile I'm going to create is for every single user within that window of time. And let's say this window of time is maybe a minute, could be 10 minutes, could be whatever you care about, but I'm going to count the number of logins for each user and store that in a format that I can use in a subsequent profile. So here, all it's saying is I'm going to add the number of logins for every single user that I see within that window of time. The second profile I'm going to create is a user distribution for all the users in that same community of people. So now I've got a table that has every user's login. So Joe Smith logged in 2 times. Jane Smith logged in 4 times. And now I'm going to create basically a standard distribution of the number of users within that user group. So now it might be, okay, I'm going to have, what the mean is or the median is for that user population that I can use for comparison. So here I'm creating that user distribution as another profile. And now I'm going to create that first enrichment, which basically creates the mean of the user login. So if I've got 10 users and the mean login is 2 logins per user per 10-minute window, maybe I care if there's another user who's logging into 10 systems, right? So these are all valid logins. These are things that would not be triggering an invalid login attempt. These are things that would usually fly under the radar of any other tool because they, on their surface, look relatively benign. But what we're able to do now is we're able to identify anomalous behavior. Who are those outliers against that same user community? In other words, baselining that user behavior against the norm, and that norm may change over each window of time. The amount of systems that a user might log into at 8 o'clock in the morning might be entirely different than the number of systems the user community logged into at 11 o'clock in the morning. But I'm building that profile of what that looks like over each window of time and then seeing who's an outlier. And now maybe I want to raise an alert so that somebody can take a look and see, is this something we need to look at? Do we have another Edward Snowden who's trying to log into all these different systems and pull this data down that he's going to take and give to somebody else and exfiltrate off the network? So the last piece that we've done here is we've actually said, okay, we now know what the mean number of logins is for this window of time. Let's compare that to each user and say, is this individual user outside some number of standard deviations from that mean? So in this case, we said it's going to be greater than 5 standard deviations for the rest of the population. So if user X has more than 5 standard deviations of everybody else on his network for logins, we want to raise that as an alert. And we can even take this a step further where we can further stratify that user community where maybe we actually care about whether or not that user was an admin or not. So this is, and I'll show you what this looks like in the UI. I may actually want to create a lower score if this is a user who does not have nearly the same permissions as an admin. So if a user is logging into more than 5 standard deviations of the number of systems, maybe that only rises to a threat triage score of 10. It's important, but not nearly as important as if we have an admin who's logging into a whole bunch of systems with his admin credentials and he's outside the norm. And that's where maybe we want to say that score is going to be 100, and we need to bump that to the top of the priority list for an operator to take a look at. So what does that look like now from an analyst perspective? So here's the Metron UI from an analyst point of view, where they would actually see the alerts that they need to triage. And this is all customizable in terms of which columns you want to take a look at. What do you want to call those columns? Excuse me, along the top where you've got these group by sections, I can group the data all by that. So if I actually wanted to only look at, for example, the scores, the high-level scores that are in the U.S., I could click on this enrichment country, and it would group all of these by country code. Or I could even click on one of these columns, and it would actually set the context for the entire window. So if I click on U.S., every single data source that I see in my alerts pane will be restricted to only looking at U.S.-based data. If I then say, okay, I only want to look at the data for this user, if I click on this user, this search will be set to include that target IP address and that user. And now the context for every single data source that I'm looking at in this window is restricted to where this logins involving this user and this IP address. So this is some of the power for how quickly I can whittle down this large number of alerts to sift through to only the very small handful that I care to take a look at within this window. And this is powered by, like I said, either Solar or Elasticsearch. This is extremely responsive, sub-second response time for being able to drill down into that information. But so here you'll see from the previous example, I have several threats that have been triaged as a score of 100. These are bubbling to the top of the list for analysts to take a look at. And I can see based on that enrichment that I have a user that's an admin user who has attempted to log into more machines than 5 standard deviations than the median number of users in that admin community. So I think this is a very good and powerful example of how Metron can identify events on your network, behavior on your network that may not be detected because it is not necessarily something that is like an invalid login or somebody trying to reach a malicious website that would normally be detected by those signature-based mechanisms. This is entirely being built off of baselining behavior across some population of entities. And that entity can be anything. It could be a user. It could be a system. It could be an application. It could be a network. It could be a subnet. Basically anything that the profiler is able to build a profile on, you can baseline that behavior and identify what's anomalous. So, you can start to think, not only can we do things like the number of logins, maybe I care about, let's use a credit card example. So if I'm using my credit card and my last 5 transactions were in Boston, and now all of a sudden, a few minutes later, I have a credit card transaction show up in Italy, that's probably something that wants to be flagged as something to take a look at. Similarly, I can do that exact same thing in Metron. So, if we've geo-referenced an IP address, for example, maybe I create a profile that creates a geo-centroid around the user's last 5 logins. And, every single time the user has a new login, it compares to the centroid of those last 5 logins to see if it's greater than some distance. So if I've got my last 5 logins in the greater Washington, D.C. area, and all of a sudden I have a login showing up from Russia or China, maybe that login credential is correct, but I still probably want to rise that up as an alert for somebody to take a look at in more detail because that's anomalous. That's outside the norm for that user's actions, for that behavior. So very, very, very powerful mechanism within the profiler to be able to build those kind of behavioral baselines and identify what's anomalous about that behavior. So where do we go from here? So I mentioned the technology. I want to talk a little bit about what Hortonworks provides. So Hortonworks basically supports 100% open source Apache software. So all of our software, whether it's HTTP, whether it's HDF, it is all 100% Apache open source and 100% Apache open community. And what I mean by that is you do have a lot of vendors who will say, our software is open source, However, they are the gatekeepers for how that software is maintained in that open source community. So it's not really true open source community. Apache is, the most well-known open source community for how it manages open source projects. So everything from Apache Hadoop to Apache NiFi to Apache Metron are all 100% open source and 100% open community. Hortonworks' business model is to provide support for those open source products and to integrate them into an enterprise-ready solution that you can deploy within your network and have somebody to call if you need help, if something goes wrong. But that's our business model, is to provide support for that. And so we like to say that every year is an election year for us in that case, because if you're not getting value out of what we do, well, you don't need to renew your subscription, and that doesn't mean the software stops working. It's open source software. I would think that we are very, very good at this because we've been very, very successful on that business model. But to talk about what we bring to the table, this is a very large and complex platform to be able to operate at this scale. And it's usually not something that, especially people who are less experienced in this space would maybe want to go do alone. So, we kind of have this phased model for how we can help people begin to adopt this technology and implement it. And this usually is almost a paradigm shift for how people are doing their existing, cyber defense, cyber threat hunting, because they're used to maybe having a tool-oriented approach. And now we're really advocating for a platform-oriented approach that provides one tool for you to do a lot more capability. So, generally we see people bringing in the platform to start to ingest some of the traditional data sources that they have there. That's that phase one where we can actually get it integrated into your environment, working with your Active Directory structure, getting it into your existing SSL environment with all the certificates, getting that all set up so you have secure communication between all the different pieces, both internal and external. Getting some of that basic dashboarding set up, some of that basic enrichment set up, and getting some of the basic tools in place to educate your users about what's in the art of the possible. The second piece of that, after you've got it in place now and start to get a comfort level with understanding what the platform is capable of, is now let's see if we can start to incorporate some of those more comprehensive data sources like packet capture data. Maybe we actually want to start doing some more comprehensive batch enrichment, machine learning models. What are some best practices around developing triage and alerting rules? Those are things that we can bring to the table based on what we've seen from other customers and how they've implemented the platform. And then last but not least, as kind of become more and more mature in the use of the tool, how do we begin to take advantage of more comprehensive models as a service, machine learning models? What are other customers doing in that space? How do we build much more comprehensive dashboards? How might we use some data science notebooks like Zeppelin to create reusable, much more comprehensive analytic tools that our data analysts can use to get much better insight into the historical information that we've stored? How do we integrate this with other tools like case management systems? Those are all the kind of things that we can assist with and help you get up and running with the tools. And so not only do we bring the platform, but we have a lot of other use cases that we've helped customers with that we can bring and implement with things like the geo-improbable logins, which I just mentioned. Unusual timing, unusual behavior on your network. Is there beaconing that's going on your network that from possible malware? All those kinds of things that we get visibility to with the customers that we deal with, we can actually bring that as that best practice to the other customers to understand how they should be implementing, what they should be looking for on their network in terms of some of these new threats, new ways of detecting these threats. That's really the benefit of having the Hortonworks support, is now you've got visibility into not only how we can help you, but how other customers are using this, what customers are implementing it, and what's those best practices. And with that, I said I wanted to stop at quarter of, and I think we're exactly at quarter of for some questions. So I will take a breath, take a sip of coffee, and see if we have any questions from the audience.
So actually, Matt, your last statement kind of leads nicely into our first question that we got, and that is, who's currently using this platform already? Who's using HCP?
Sure. So we've kind of had several different customer journeys that we've worked with some customers on, some for a long period of time and some who have actually come up with some very interesting business models more recently. So we've had some customers that have actually done some co-development with us for the past several years on this, like Capital One. They use this to detect a lot of anomalous behavior on their network. And I think the anecdote I heard from I think it was when they gave this talk at DataWorks Summit several years ago, is that when they first deployed this on the network, within the first 4 hours of having it deployed on their network, they had detected anomalous behavior that they had never seen on their network before. So we certainly have some very large customers who have deployed it in sort of that traditional security SIEM tool, big data tool. But what's more interesting is we've actually seen some more customers now who are very interested in deploying this in a managed security service capability, or MSSC. So we have recently just signed an agreement with PSSE Labs to be able to offer this as a managed service that they can host and operate. And we've also got some other customers. I believe Telstra in Australia is I think they're either the largest or second largest ISP in Australia, is using this as the basis for their SOC platform, that they are also offering this as an MSSP capability to some of their customers. And last but not least, we've just also signed a major U.S. telco provider, who I don't think we're at liberty to release their name yet, but everybody would know the name, that is also going to be using it in the same capacity for providing it as a MMSC capability to their customers. So again, we've certainly seen people deploy this on their networks as a standalone capability. But we also see some very, very interesting opportunities from people who are now looking to not only deploy this for large scale on their own networks, but then how can we offer this to our customers as a managed service as well?
Great. And we do have one more. We have somebody who's interested in wondering, do you guys provide both hardware and software, or is it one or the other?
So Hortonworks provides predominantly software. We provide support for open source software. We do have a very rich community of partners. Obviously some of the big names that would come to mind would be like Dell or an HP in terms of hardware vendors. We also do have some system integrators that can build the turnkey solutions that are both the hardware and software together for HCP. So if you go to Hortonworks, I believe we have on our integrators page that list of the integrators. But this is also an interesting question in terms of how can this be deployed, right? So not only can this be deployed on your traditional on-premise hardware, we actually are starting to see a lot more of our platforms deployed onto cloud-based platforms. So, for example, you could deploy this on Amazon. And as a matter of fact, I believe if you go to our website, if you're interested in learning more about HCP, there is a single AMI instance of Metron that you can use to poke around and actually understand the capabilities and use the system. Obviously, on a single AMI, you're not going to be running this at massive scale, but it's certainly a great starting point to actually play around with the tools and understand what's in the art of the possible. So, this can be deployed on cloud, it can be deployed on-prem on hardware, or you can actually work with an integrator who would actually build a turnkey solution. And last but not least, like I said, I mentioned PSSC or some of those other options where we actually have people who are going to be offering this in a managed service capability. So lots of different options for how you might want to deploy this if you didn't want to procure your own hardware for this. But like I said, if you did, this is commodity hardware. The idea is you just buy a bunch of massively redundant, inexpensive pieces of hardware with inexpensive drives and put it in a rack. You don't need big, expensive SANs or any of that infrastructure. It's commodity standalone hardware with commodity drives. So it's a very scalable and actually very cost-effective solution.
Great. All right. Well, thank you, Matt. This was very insightful. I look forward to maybe doing part 2 of this with you. We will be sending out the slides to everybody who was on the call. If you have any questions, I will also be distributing contact information. And thank you very much.